to show this experiment. It's ongoing. The results are definitive enough that we're definitely putting full force effort toward it. What it resulted from was I was in contact with a young engineer a week ago who explained that he had been working with SEC exciters and was putting the L3 coil on the output side rather than off of the output of the SEC. And we did a quick test. I think there's a video I put out there right after I came back. And what I've got here is something which is very, very interesting, and it defies logic at this point in time. Here's a SEC exciter, and off of the exciter I have a 1,000 ohm resistor, 1K ohm. This is where L3 would normally connect directly back to the collector L2 junction on the board. It hooks to a 6 by 6 centimeter by 2 centimeter aluminum block. Here's a tub of water. Here's kind of what the water looks like. It's a plastic container, food container, filled with ordinary tap water. On the other end, we have a similar aluminum block, 6 by 6 by 2 centimeter, connected to L3. And you see that here we have the aluminum block connected to that 1K ohm resistor back to the exciter. And here we have, and I'll show this to you so you know there's no batteries or anything. Here we just have an aluminum block, 12 LEDs, AV plug, and an L3. Okay, and we're driving that at this point in time 18 volts, 26 mils, 400 milliwatts, give or take 2 milliamps for the accuracy of this particular device. Let me show you the ambient temperature. The ambient right now with this particular thermometer is 25.2. This one here, which is calibrated NIST with a NIST standard, is 25.6. And now what I want to do is take a temperature gun for you and take and hold this out here, and I want to shoot that water, and it's 24.4 call it. Air conditioning's running now. Remember, the ambient is 25.2 and we're 25.4 on the calibrated unit. Let's shoot this one right here now. And we see it's 23.2. Now this unit has been running for probably, I'd say, 3 hours. The first hour I didn't have any insulation around it. I added the insulation. Obviously you can see that there's still a lot of it exposed. But nevertheless, I think you understand the anomaly that's taking place here. The air conditioner just switched on in the lab, so now you can see the ambience dropping, 25.1, 25.2. We'll take a look at this standard, and it's actually still 25.6. I hope it's not too close to this guy. No, it's 25.6. So let's go through the heat gun again. Let's go ahead and shoot that water. This is my control. There we go, 23.7. And here, if we take and shoot this one, (22.9), 23. So you can see there's a ratio there. One's a bit lower than the other, and also this one's still a bit close to this aluminum block. You can see the bubbling in there. That's quite common. If it's too close, I'm going to have to move that away, but I wanted to get it up close enough that I could shoot it in the same video so you actually knew what it was. So we're 25.6 there. We're still 25.1 there. And we're still running 26, 400 milliwatts, plus or minus 2 mils, so that of course will change your power. Let's shoot this guy one more time. He's now 22.9. Let's shoot this guy. 24.5, 24.3. So you can see what's going on here. You're going to have to take my word for it. I haven't doctored the water. It's straight tap water. And the distances now, I gave you the size of the aluminum blocks. They are separated by 11.7 centimeters. That's the distance from this block to this block. So that's quite a span. If I were to lift the tub of water out, everything quits, obviously. But I think it's well worth putting this up now, because it will be a preliminary to what I think we're going to find as we keep working with this. What's going to happen now, we cannot take active temperature measurements of this water, because even touching the plastic case that it's in upsets it. Well, let me show you here. Okay, let me touch this. Little difference, right? Touch this one. Big difference. Touch this one over here. Difference. Touch this side of the 1000 ohm resistor. Touch this side of the 1000 ohm resistor. Kind of gives you an idea where the impedances lie too. So anyway, preliminary. No claims yet. I think it's obvious what's taking place here though. And we'll take and just check all these out one more time. 25.6 still. Let's shoot it one more time, just for the heck of it. Okay, and let's call it 23.9. Let's shoot this guy again. 22.9. I hate these guns. Anyway, what we actually do is, after I've run it for a while, I'll take the lid off, stick one of these calibrated thermometers into it, and get a reading with the circuit off. And what is coming down the road is to completely encase this unit in that blanketing, so we can take and see if it gets cooler, or if indeed it stops the reaction altogether. So okay, enough for now.